Hello friends, today I am going to discuss the temperature stress and strain, or it is also known as thermal stress or strain. Thermal or temperature stress and strain. Whenever a body is subjected to heating or cooling, it expands or contracts. Expansion of a body is due to rise in temperature and contraction of a body is due to fall in temperature is called as natural or free deformation. It means if we heated a heat supply heat to any body, then it will get elongated due to higher temperature, and if you cool any body, then it will get compressed due to lower in temperature. That change in length is known as the natural or free deformation. Means कोणत्याही बॉडीला हीट अप्लाय केल्यानंतर ती बॉडी एक्सपांड होते आणि हीट रिमूव्ह केल्यानंतर ती बॉडी काय होते, कॉन्ट्रॅक्ट होते. त्याला आपण बोलतो नॅचरल डिफॉर्मेशन, बिकॉज इट इज ड्यू टू नॅचरल डिफॉर्मेशन. लो टेम्परेचर स्ट्रेस इज डेव्हलप्ड इन दी बॉडी इन नॅचरल डिफॉर्मेशन. मीन्स कोणत्याही प्रकारचा स्ट्रेस याच्यामध्ये डेव्हलप होत नाही टेम्परेचर स्ट्रेस. जर बॉडी फ्रीली इलॉंगेट होत असेल तर, किंवा फ्रीली कॉम्प्रेस होत असेल तर. जर याचे दोन्ही एंड जर आपण फिक्स केले तर त्याच्यामध्ये टेम्परेचर और थर्मल स्ट्रेसेस डेव्हलप होतात. ते आपण पुढे बघायचं आहे. Consider a length of a bar L. Alpha is the coefficient of linear expansion or contraction, expansion for heating and contraction for cooling. T is the rise or fall in temperature. dl is the change in length. This all the dimensions or notations are shown in the figure. Consider a body is subjected to rising temperature T degree centigrade, having a linear coefficient of expansion alpha. Therefore, change in length dl is directly proportional to L alpha T. Change in length is equal to L alpha T. This is the standard formula when body is subjected to heat. Therefore, change in length is calculated by L is the length of the rod, alpha is the linear coefficient of expansion, and T is the rise in temperature. Therefore, strain, this is the total change in length. Strain is nothing but change in length upon original length. Change in length is L alpha T and original length is L. L gets cancelled and strain is equal to alpha T. This is the equation of strain. And now suppose this body is fixed by both the ends, then thermal stresses will be developed and no strain, because there is no change in length, because it is restricted by two fixed ends. Here is the change in length dl because there is no stress, because its end is free to expand, and thermal strain is developed, that is change in length upon original length. And in second case, thermal stress is developed because expansion is prevented by these two ends and no strain will be developed because change in length is 0. If the free expansion due to rise in temperature is prevented by fixing two ends as shown in figure, the thermal stresses produces which is compressive in nature. For such a figure, if free expansion is prevented due to rise in temperature, then thermal stresses will be developed, that is compressive in nature, because this body gets expanded due to rise in temperature and these fixed ends are compressed. These two bodies means याच्यामध्ये जर टेम्परेचर आपण राईज केला आणि त्याचे दोन्ही एंड्स फिक्स केले तर त्याच्यामध्ये कॉम्प्रेसिव्ह स्ट्रेसेस, थर्मल स्ट्रेसेस डेव्हलप होतात. याच्या उलट, if the free contraction is due to fall in temperature is prevented by fixing two ends as shown in figure, then thermal stresses produces which is tensile in nature. That means if body is cooled, that is the temperature is reduced, then it will get contracted, but due to these fixed ends, त्याच्यामध्ये ह्या दोन फिक्स्ड एंड मुळे काय होतं, त्याच्यामध्ये टेन्साईल स्ट्रेसेस डेव्हलप होतात. थर्मल टेन्साईल स्ट्रेसेस अशा प्रकारचे दोन टाइप्स आहेत. फर्स्ट टाइप जो आहे राइज इन टेम्परेचर असेल आणि बोथ एंड फिक्स असेल तर कॉम्प्रेसिव्ह नेचर, आणि सेकंड आहे फॉल इन टेम्परेचर असेल बोथ एंड फिक्स असतील तर टेन्साईल इन नेचर. हे लक्षात ठेवायचं. Thermal stress and load. How to calculate the stress and load for such a problems? Thermal stress, we know that Young's modulus is equal to stress upon stress. Therefore, stress is equal to Young's modulus into strain. And we calculated value of strain is equal to alpha T. Therefore, stress is equal to E alpha T for temperature or thermal stress. And load P is equal to, we know that stress is equal to force upon area, therefore force is equal to stress into area, and value of stress is equal to E alpha T. Put the value of sigma is equal to E alpha T into A, that is the total load. These two equations, these two formulas we have to use to solve the problems on thermal stresses. Let us discuss the first problem. Let us solve first problem, that is a rod 10-meter long at 10 degrees centigrade is heated to 70 degrees centigrade. If the free expansion is prevented, find the magnitude and nature of stress induced. Take E is equal to 2.1 into 10 raised to 5 Newton per millimeter square, and alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. Rod 10-meter long, L is equal to 10 meter. Temperature difference 10 degree is heated to 70, that means temperature difference is 70 minus 10 60 degree. T is 70 minus 10 60 degree rise in temperature. E is equal to given and alpha is also given, and ask what is asked, find the magnitude and the nature of stress. Magnitude means we have to calculate stress, and nature means tensile or compressive. The magnitude and nature of stress sigma is equal to E alpha T. Value of E is given, alpha is also given, and T is also given. Put these all the values, we will get 151.2 Newton per millimeter square. Here is the problem for rise in temperature 10 to 70 degree. Therefore, nature of stress is, or nature of load is compressive. Since expansion is prevented, that means rise in temperature. This is called as compressive stress. Second problem, a square bar rod 10 millimeter by 10 millimeter in cross section and 1000 millimeter long is fixed at both ends. Determine end reactions. End reaction means load. We have to calculate load. Due to rise in temperature 50 degrees centigrade, take E is equal to 2 into 10 raised to 5 megapascal, and alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. L is equal to length 1000 millimeter. E is given. MPM is directly Newton per millimeter square. Alpha is equal to 12 into 10 raised to minus 6 per degree centigrade, and T is equal to 15 degree centigrade. A is cross section 10 by 10, 100 millimeter square. Temperature stress sigma is equal to E alpha T, standard equation. Value of E, alpha and T. Solve it, we will get 120 Newton per millimeter square. And nature is compressive because here is also rise in temperature. Due to rise in temperature, that means nature is also compressive. We have to calculate end reactions, that means load. P is equal to sigma into A. Sigma means E alpha T into A. Value of sigma is equal to 120 and A is equal to 100. That is 12,000 Newton is load. Next problem is a steel rod of 4.5 meter long, 4.5 long is at a temperature of 28 degrees centigrade. Find the free expansion of the rod when the temperature raises to 78 degrees centigrade. If the free expansion is completely prevented, find the magnitude and nature of temperature stresses and strain developed. Alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. A is equal to 2.1 into 10 raised to 5 megapascal. Length is given 4.5 meter, 4500 millimeter. T1 is equal to 28, T2 is equal to 78. That means rise in temperature. We have to take difference of both of these. Rise in temperature is T2 minus T1, that is 50 degrees centigrade. Alpha is given, E is given. First, free expansion L alpha T. This is the formula of free expansion, that is 2.7 millimeter. First condition is if this free expansion is completely prevented. No, sorry. Find the free expansion. Free expansion means L alpha T, that is 2.7 millimeter. And second case is if the free expansion is completely prevented, that means we both ends are fixed, then we have to use thermal stress equation and thermal stress and load equations. Thermal stress, that is temperature stress, is equal to E alpha T. Put value of E alpha in T, we will get 126 megapascal, that is Newton per millimeter square. It is also compressive because rise in temperature. And second is asked temperature strain. Strain is nothing but alpha into T. Alpha, put the value of alpha and T, we will get 6 into 10 raised to minus 4. That is also in compressive in nature. Next problem. The rod of 300 millimeter long and 20 millimeter in diameter is heated through 100 degrees centigrade and the same time pulled by a force P. If the total extension is 0.4 millimeter, what is the magnitude of P? That means in this problem, temperature is also provided and load P is also provided. Therefore, change in length is due to two loads, that is rising temperature and force P. And we have to calculate force P. E is given, alpha is also given. Length of the rod is 300 millimeter, diameter is 20 millimeter, rising temperature, that is 100 degrees centigrade. Total extension is 0.4 millimeter. Young's modulus is 2 into 10 raised to 5 Newton per millimeter square and coefficient of expansion alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. Here the total extension is 0.4 millimeter is due to rise in temperature and due to force P. Therefore, we have to use both the equations formula. Total extension of the rod is equal to due to free expansion plus extension due to force P. Well, the equation of free expansion is L alpha T. Delta L is due to force P. 0.4 is the total extension. L alpha T we will get 0.36. Put DL as it is. Therefore, we will get DL is equal to 0.04. 0.4 minus 0.36. This 0.04 is due to load. Put this value in change in length formula, that is DL is equal to PL upon A. We know DL 0.04, P we have to calculate, L is equal to 300, A is equal to pi by 4 d square and A is 2 into 10 raised to 5. After solving this equation, we will get value of P is equal to 8.377 kilo Newton. This means such a type of a problem we have to use free expansion and due to load expansion, that is PL upon A and free expansion L alpha T. Again such ह्याच्याच प्रकारे दुसरा एक प्रॉब्लेम आपण सॉल्व्ह करूया. A steel rod of 20 millimeter in diameter, D is 20, 1.2 meter long, L is equal to 1200 millimeter, heated through 120 degrees centigrade, T is equal to 120 degrees centigrade. At the same time, pulled subjected to axial pull of P, that is load P is applied. If the total extension of the rod is 3 millimeter, total extension is 3 millimeter, what should be the magnitude of P? That means value of P we have to find out. Coefficient of expansion is 12 into 10 raised to minus 6 per degree centigrade and Young's modulus is 200 GPa. GPa means kilonewton per millimeter square. Total extension of rod is equal to free expansion plus extension due to load P. Total extension is 3 millimeter. Free expansion L alpha T, put value of L alpha and T. We will get 1.728. Therefore, change in length DL is equal to 3 minus 1.728, that is 1.272. This change in length is due to force P. Therefore, we know that DL is equal to PL upon AE. put value of DL 1.272 is equal to P. L is equal to 1200, area is equal to pi by 4 d square and into 200 kilonewton per millimeter square. Therefore, load P will also get in terms of kilonewton. Value of P, that is load, is equal to 66.6 kilonewton. Thank you.